Hello, fellow Space Apps 2018 enthusiasts. We are Team groB, designed by nature. Imagine if you had an army of robots on the space station that by themselves they weren't very powerful, but together they could do great things.
The next few slides I will go over the damage detection algorithm for our spacecraft situational awareness and also discuss the swarm intelligent approach that we have taken. Our idea will consist of a queen and subagents. The subagents will deploy from the queen and the queen will rotate as the subagents collect the sensor input. The sensors underneath the subagents are shrouded to reduce noise and point normal to the spacecraft surface. The tether will provide power and communication between the subagents and the queen. The rotational track gets smaller as the sensors are moved closer to the center of the scan area. The subagents will move in a 2D measurement frame, and the aggregation, or the queen, node will move in a 2.5D around the spacecraft. The queen does all the communication, and the subagents have no awareness of other agents except the queen. The decision of whether there's damage or not is a weighted sum of the different subagents, and the individual subagents are a simple perceptron. To scan the Zarya module, if you break the surface into 1 centimeter square surfaces at 100 subsurfaces per second, it would take about 5 hours and 15 minutes. The queen is tethered and will do the initial scan. It has nozzles for positioning using gaseous propellant, and it is tethered to the spacecraft for power, and also can send information back and can be used for failure. Some of the agents are infrared, optical, and synthetic aperture radar, and we have also incorporated different nature concepts.